It's okay, Emily. I can help you with oxyacids in chemistry.
Thanks, Molly. These are the rules for oxyacid naming. The first rule is that it contains hydrogen, oxygen, and a third element. The second rule is the anion suffix. If the suffix is ate, you change it to ic, and if it's ite, you change it to
Oxyacid naming are if you have the suffix sulf or phos, the roots are going to change to sulfur and phosphor. The fourth rule is that it always contains a polyatomic ion, which can be found on your polyatomic ion sheet. Yes. The fifth rule in naming is that it does not contain the prefix hydro like other acids.
examples of oxyacids. We are going to name HNO3. First, you can look on your polyatomic ion sheet, and NO3 is right here. So, NO3 is nitrate, and when you look on your notes, you can see that 8 changed to ic, so it'll be nitric. And you have to always add acid at the end, so it's acid. And the next one, HNO2. You can look at your polyatomic ion sheet again, and NO2 is right here, and it's nitrite. And when you go back and look at the rules, ite to us is the suffix rules, so it would be nitrous acid. And you don't add hydro in oxyacids.
The next problem is number 3, carbonic acid. We have to convert carbonic acid to a chemical formula. We know that the suffix ic will change to ate. And when we look at our ion sheet, carbonate is CO3 with a charge of -2. We then have to balance out CO3 with H's because of the -2 charge. So the solution would be H2CO3. The next one is number 4, which is hypochlorous acid. We have to change hypochlorous acid into a chemical formula. And we know that the suffix us changes to ite. So when we look at our ion sheet, we find that hypochlorite is ClO with a charge of -1. We then have to balance out ClO with H because an H has a positive charge and ClO has a -1 charge. So they cancel out to make HClO.
Great job, Emily. You get an A.